In our previous piece of learning, we learnt about the sigma and the pi bonds. So knowing that the sigma bond is the first bond that forms between carbon atoms when we've got a chain of them, or in this case a circle of them, so a hexagon of them. And the pi bond being the second bond that forms, and the nature of these bonds are slightly different. So we can have organic compounds that are what we call conjugated systems, and that means an alternating between single and double bonds, and I suppose technically between single and triple bonds as well. The idea is you've got a pi bond here, no pi bond here, a pi bond here, no pi bond here, and so on. So it's alternating as to where we've got our pi bonds. Now, when you've got a system like this, and the chemical I've got here, I haven't shown the hydrogens, but the chemical I'm showing here is called benzene. When you've got a system like this, the pi bond electrons can naturally jump from between these two carbons to between these two carbons. And in doing so, this would then have 5 bonds, so it would push this one around. And in doing so, that would push this one around, and you can see how it becomes this structure here. So these two structures are exactly the same, not just because they're only mirror images of each other, but because one becomes the other naturally. That's what this double-headed arrow means, that this goes forwards and backwards equally. And this happens because the pi bond electrons are able to move around the structure. So this can happen with things that are cyclic, this movement of pi bond electrons, or things very, very large like a polymer. If you've got a conjugated system in a polymer, then you can get the same sort of thing happening. And what you can actually do in a polymer is you can make it even more pronounced. You can make that jumping of electrons, that chain reaction that is shown by this thing in the cycle here, this chain reaction even more pronounced if you do a thing called doping, where you either add more electrons or remove electrons, a bit like rubbing a plastic rod would do, but you can do it chemically, and that's called doping, and we'll do a video on doping a bit later. Just so you're aware, for your chemistry knowledge, when this conjugated system happens, neither of these structures is technically 100% correct. It's actually sort of somewhere in between. Each of them ends up being sort of a 1.5 bond. The pi bonds, the 3 pi bonds, 1, 2, 3 pi bonds, belong to the whole structure, the whole cyclic part of the structure. So the way we actually draw it is what I've got down here with my black things representing my carbons. This circle represents the pi bonds, and the lines represent the sigma bonds that hold the carbon together. We simplify that even further in organic chemistry to here, because we don't often show the carbon atoms. Wherever 2 lines meet, a line is a sigma bond between 2 carbon atoms. So this is a carbon atom, sigma bond, carbon atom, and so on. The circle is showing that there are pi bonds shared by this whole thing. And because there's 6 carbon atoms, there would be 3 pi bonds in this molecule. So, just a little bit of a recap. Conjugated systems have got an alternating double and single bond. Now, technically, I suppose you could have alternating triple and single bonds, because triple bonds have got 2 pi bonds in them. But we're going to focus on double for this example. Then, because of this system, you can have it that there is movement of pi bond electrons, and that starts a chain reaction. So sort of a flow of electrons, as it were. What this ends up doing is meaning that the pi bond electrons are actually shared by the whole molecule, and we can represent that as a circle here if it was something cyclic. We can also apply this understanding to polymers where they have a conjugated system, where as soon as I force one of those pi bonds to move, say with an electrical impulse here, then it will have a chain reaction along the polymer and make it conduct electricity, albeit poorly, because it is a non-metal. Now the last bit on this is that we're going to have to learn about doping, because doping in polymers can actually make them conduct electricity even better.